Lesson 16, Curve Sketching 1. We're going to sketch the parabola y equals 2x squared minus 4x plus 3 using the techniques of calculus. Now, first of all, we'll differentiate this function. So I'll have dy dx is equal to 2 comes down, multiplies by the 2, it becomes 4x, and this becomes minus 4. Now, this is the gradient function. So this determines all gradients on this curve. So at this particular point, we'll have a certain gradient. Over here, we'll have another gradient. At this particular point here, the gradient, I draw a line there, that gradient, you can see the slope of that line is 0. Now, if we let dy dx be equal to 0, that will then determine the x value of the vertex of the parabola. So we'll do that. We'll let dy dx equals 0 to find the x value. So 4x minus 4 equals 0. 4x equals 4. Simple little equation. X is equal to 1. So when x equals 1, we then need to find the y value. So we'll substitute that back into the original equation, and we get y is equal to, putting 1 here and square it, we get 2 minus 4 plus 3. So the y value is 1. So the coordinates of the vertex here was 1, 1. Now obviously we need to have more points than that. This is a very convenient point to find because when x equals 0, right, all these go out, and we get that y is equal to 3. So this is the point 0, 3. Now remember, we found also the axis of symmetry here. So this distance here must be the same as this distance here. So we can get very quickly this other point, and we know that this distance from there to there is 1, so this must be 1, so the total distance is 2. So that's the point 2, 3. Okay, and once we plot those points, we would normally just draw that curve, right? And that is how you draw the curve y equals 2x squared minus 4x plus 3 using the calculus. Okay, then the next problem we're going to draw is interesting because I've rearranged this so it's in a sort of factored form to demonstrate the fact that you don't need the calculus all the time. But we'll start off and we'll do the same thing. We'll differentiate this and locate the vertex, etc., and then we'll have a look what's going on. Now I'm going to use y dash just for a bit of variation. And when we differentiate that, that'll go out. Now the 2 will come down the front, so that becomes minus 2. And using the chain rule, right, we'll just take 1 off and look inside, and we just get the 1 there. Okay, so we'll let y dash equals 0 to locate this vertex here. And so we get minus 2 into x minus 2 is equal to 0. So x equals 2. So when x equals 2, putting the 2 back in here, we'd see that becomes 0, and y is equal to 3. So this is the point 2, 3. Now we didn't have to go through all that because what's happening here is if you look at this part, when you square that, that's always going to be a positive number. So with 3 minus some positive number will reduce the value of y. But when it equals 0, that's the maximum value that y can ever get to, y equals 3. So this is the maximum value, the highest point, which is 3. You've got it straight away. And that occurs when x equals 2. So we could have simply just put in 2, 3, and we've got it straight away. And it's important to realize this because once you know the calculus, don't blindly use it all the time. So we've got the point 2, 3. We've also got this point over here, right, which is, again, the same sort of thing. When x is equal to 0, so x is equal to 0, a little bit of work to do here. Y is equal to 3 minus 2 all squared. So it becomes 3, that becomes 4, and of course y is equal to -1. So this is the point here, which is 0, -1. In the same way on this side, we'll go with to add 2 onto this, so it becomes 4, and it'll be -1. Now, the previous example, it didn't cross the x-axis, so if you're asked to find these points, there's a very easy way of doing it in this particular form. Now, we'll let, this time, y equal 0 to locate where it crosses over the x-axis, because the equation of the x-axis is y equals 0, and we see that 3 minus x minus 2 all squared equals 0. Now, don't expand this out. Right, you could expand it out and use the quadratic formula. It'd be a rather long and pointless task. That's right, that becomes x minus 2 all squared equals 3, taking this across the other side. And of course, taking the square root, that becomes x minus 2 equals plus or minus the square root of 3. And taking the 2 across, it becomes 2 plus or minus root 3. So this point here was the point 2 plus root 3, and this point here was 2 minus root 3. Now, it's very important that you don't need to plot those points, right, to draw the sketch the curve, but sometimes you'll be asked to locate the x-intercepts and the y-intercepts. So this is how you do it.